Okay, so now I'm moving on to the next phase of this particular module. We have electrical services, importance and implications on building design. So the question is, why do we have to learn electrical services? So we are architects, we have our own consultants to take care of several other verticals. Like we have structural consultants. So we have so many of services, so many of these services happening. So why do we have to know all this is the question. So what is the importance of these in a building design, right? So this is something which is very much aligned with our syllabus, in terms of syllabus objective, in terms of the importance of these services in our building design, right? So I have put the sequence of these in such a fashion that it happens in your VTU syllabus, because you in your building services 1 you study about plumbing and sanitary services. Services 2 you study your electrical services. Service 3 is your HVAC and fire alarm and vertical transportation. And finally you complete your services series with acoustic services, right? So acoustics being a special vertical I have not put here, but otherwise we have these basic plumbing, electrical and HVAC happening here. So what makes up this services? Around 7 to 8 percentage, according to some estimate, in a building space. We are talking about space here. Space is consumed by all these MEP services. So if we have to, what makes up that 7 to 8 percentage? It depends largely on the type and nature of the building, and in some areas we have HVAC occupying majority of the spaces. In some areas we have electrical rooms and all that. So that is largely on the nature of the building or the typology of a building. But if we have to try to understand, get into this particular aspect of what is happening, what makes up the electrical services, what is that number of percentage that an electrical services is going to take. We have panels, we have distribution boards, we have circuit breakers, we have distribution systems, and so much and so forth, right? So all these are going to have their own space in terms of the unit, L by B by H, but it is not just that, because there is always a constant flow of electrons vertically, horizontally, also getting in contact with, or it happens in a surface. Sometimes we bury the conduits inside the building, inside the wall. Sometimes it is exposed. The risk of electrical hazard is going to be more. So that makes it very important to understand that how are we going to deal with this. So when there is an electrical room, there are several standards that has to be followed. So it is going to take up some of our space, at least, apart from our aesthetic component and the architectural component of the spaces, because of the risk that is involved with designing all this, right? So we will quickly try to understand how is it different and important from other building services. Is a question I would love to, this is very simple in terms of understanding, but most of the time it is very we've been very ignorant about it. So if we have to talk in terms of why electrical services, of course each of these services are unique by themselves, and the beauty of all the services is it's pure common sense, right? So why is this important or and different from other services? When we learn about plumbing services, we must have come across okay, let us take plumbing. So what is going to move horizontally, vertically and all that is going to be a set of what do you say, some liters of quantity of water which is going to move up and down and back and forth, right? And in the same building, let's say plumbing is completed in a particular building, in the same building now we are going to put a different set of pipes or mediums which is going to take some other material which is electrons, right, which is again going to move back and forth and also up and down. So these two are very important in a building, but they can't talk to each other. You can't combine them, you can't put them anywhere close. The moment these two come in contact, you obviously know what is the result. So every time we plan these services, we need to remember that these two have to be definitely separated. We can't even say I have one shaft and all my plumbing, electrical is all going to happen within that. That is definitely not an answer to any of your problems, services related problems. So in the worst case, if you still can't understand what's to be done, we need to make sure that we have a couple of shafts. One is for electrical, one is for plumbing, and they can't shake hands with each other. Simple as that, right? So now we have covered plumbing and electrical, how these two are different and how it is unique and important by itself. Now we have now we spoke about how different they are. Now we have to talk in terms of how unique they are. Let's say for the movement of water in a different shaft vertically and horizontally, you need to have something called as a motor, right? Which is happening at depending upon the height of the building. It happens in the ground. It happens at regular intervals of a building, depending upon the horsepower of a particular motor. So to power up a motor, what do you need? The question is, we need to move water up and down. What is needed is a motor, and for the motor to work, what is again needed is electricity. So they have to indirectly shake hands with each other, but they can't come in contact with each other. So similarly, if we move on to our HVAC services, there are several huge machineries which is going to be in the basement, or it is going to be in the rooftop of your several G plus 10 plus high story buildings or malls or commercial complexes. So all these machinery, the mechanical equipments are going to require huge amounts of power, right? And the same HVAC, some of you must have seen cooling towers in some of the building terraces, commercial building terraces, which is going to have a fan rotating, etc., etc. Let's not get into the detail of it. That particular equipment needs both water and as well as your electricity. So these services are so intertwined with each other that we can't really separate them, but all that we can do is use our common sense and design a system such a fashion that they shake hands in a much gentle fashion than getting in touch with each other, creating a huge clash, right? So this electrical or for that matter any services is going to be unique by itself. So how all these are going to be interrelated, again fire, the red pipes that we see it is fully loaded with water, and you have sensors. Some of these sensors require electricity. So like I told you before, all these are going to have a strong relationship with each other. If not followed, it is going to be a major disaster. We have this particular question repeating often in an exam. So the importance and implications on building design due to electrical services. So I will switch to a board explanation where we will quickly try to understand whatever I just spoke. Right? Again, why we shifted to the board is to understand the implications of electrical services on building design. Right. So we spoke about the types of services in terms of your plumbing services, how that is unique or important by itself. Next is in your electrical services. Third, I spoke about HVAC or the mechanical services. And we have other services like your vertical transportation, lifts, fire, and you have specialist services, acoustics as per your syllabus, right? So let's leave this, keep acoustics aside for now. So you take these. So it is all about, I spoke to you about how it is vertically and horizontally. The movement of it is managed vertically and horizontally. It is all about that. So when you talk about plumbing services, you have something in the bottom pumping all the water to the tank, and again it is flowing to all other flows vertically, and it is again taken to the horizontal rooms according to your requirement and design. So similarly, in the case of plumbing services, it is the water that is moving In case of electrical services, it is the electricity or the electrons that is moving. So right, so these if you think it is all about vertical and horizontal movements, it is not just that, because all of them have their own what do you say, they are all unique by themselves, so you can't combine water and electricity. So there are people we come across this common idea where, imagine if this is a plan of this building, we come across saying, sir, I will give something in the end which is a shaft, and all my water, AC, electrical is happening right here. So the electrical, water, HVAC, all that happens in this, let's say 1.5 meter by 1.5 meter shaft. So they just happen and say that whatever happens is happening inside that, and it is all sorted. That is not how it is going to work, because I told you they can't interact with each other much. So we will tell them when and how they have to interact. So if you allow them to interact, all these guys within themselves, it is going to be a disaster. So we are not going to let that happen. So we will tell them where, how it has to be done. So simple way to solve this problem is, we will have a couple of shafts. Of course, it is going to be through the shaft arrangement, but we are going to call this as the plumbing or the public health engineering shaft, where it is going to have only water movement, right? Where you're free to have another shaft where you call this as electrical shaft, which is just going to take care of all your electrical requirements. So similarly, you're free to have another shaft which is your HVAC ducts, which is going to take your HVAC ducts, which is called as HVAC shaft, right? So the idea is, we are not allowing them to talk to each other, right? So the moment they come in contact with each other, it is going to be a mess. So of course there are places where somebody can argue, okay, water and electrons we understand, they don't have to talk to each other. What is the point if I can just combine my electrical and HVAC shaft? Yes, it is not as critical as water and electricity or electrons. But imagine, in case, what happens here is, so in case of, like I told you, in plumbing it is the water that is being moved up and down. In electrical it is the electrons. In HVAC it is air, right? So it is being moved up and down, back and forth in all directions. So what happens is, water and electricity, because this is going to have an impact of fire component in it, we don't combine them. What happens if we combine these two? If again there is a fire component, if there is a break, if there is a fire that is breaking open, and this particular air, because it is moving air in huge quantity up and down and to all other flows horizontally as well, the possibility or the growth or the rate of growth of fire is going to be more, because we combine these two. So imagine in this case where we have a separate electrical shaft, separate HVAC shaft and PHE shaft. If there is any mishap here, it is getting contained only there. Of course, I'm not saying we are avoiding every possible problem just by separating them, but we are of course avoiding a basic or the main or the important part of their interaction, where we can still contain some of those unprecedented circumstances. So now, keeping this aside, I will just quickly brief you about this particular area. So every time we have an electrical shaft, let me draw a plan of this. So we have, let's say this is loaded with a couple of rooms. Let's say this is a doubly loaded corridor, right? And we have this entrance and then the staircase going here, and again we have this doubly loaded corridor. And in the section, this is going to be let's say a G plus 6 or 7 structure with a typical plan. Right, so we have this entrance in the center and floor number 1, floor number 2, 3, 4, 5. Okay, let's say it's G plus 1, 2, 3, 4, 5, G plus 5 structure. This is the entrance. Right? So, of course, we know that we can the way electrical and electrical engineer can strategize his plan can be based on a variety of factors. But for our understanding, let us divide it into two zones. So one I'm going to say zone A, the other one is going to be say zone B. So all that I'm going to do for this building is going to this particular assignment, I'm going to supply electricity for the entire G plus 5 floors. Let's say we can have a basement as well. Okay. Right. So we have two zones, zone A and zone B. And of course, like I told you, we are going to have shafts on either sides. Okay, so we are going to get the government supply and we will be discussing about it in the upcoming modules. Let's say we have the electricity in our building and we have this happening in, let's say I'm going to identify this particular room. Let's not get into the size of it. This particular room as the electrical room in this side and this particular room as the electrical room in this side, right? So this is going to be simple idea, or the design is this particular room has to be repeated in every other floor so that they can establish a common contact between the floors. So if you have to make a section, if I have drawn the section here, so you're going to see this particular electrical room right on top of each other. Right? So this avoids most of the problems. So any building that and every building that you're going to design, the most easy way of understanding or avoiding clashes between the electrical services is you have a room which is called as your electrical room happening right on top of each other, right? But what does this electrical room actually do is, what is actually doing is, it not only communicates between the floors, but it should also communicate with other rooms in the floor, other spaces in the floor. So there is a vertical communication as well as a horizontal communication. So if I have to blow this part alone, how it is going to look is, we have this electrical room. Usually as a standard, whatever door that we are going to show, even though we say the doors cannot open on a corridor in our regular architectural practice, this room, which is your electrical room or the services room, will always have its door opening outside. So if in case of a fire somebody has to rush in, the idea is they should be able to quickly come out of it, and this will always be a fire rated door depending upon the code and standard, right? So it should always, remember, the door should always open outside, right? And we spoke about vertical transportation and horizontal transportation or communication, let's say. So we know how they are going to communicate horizontally is above your ceilings, through the walls. There are several ways of communication which can go to every individual room for the light and fan that we have, and we have false ceiling and all that which can happen. But over here, how do they communicate vertically is through a shaft. So they are going to have a shaft. This is called as your electrical shaft, which will again have a door depending upon the design opening outside for somebody to inspect, and this is good enough for somebody to walk. So this is where all your bus bars, rising mains and all that will be. So this will have a series of wires on several cable trays, bus bars, communicating with each other floor, right? So this comes inside to the boxes which is kept inside. These are almost height of 5 to 6 feet, panels designed by the electrical engineer. So these panels are getting fed by these vertical risers, right? So this is how they communicate vertically, and after, when it comes here, these are the panels. So they communicate horizontally, mostly above the ceiling, okay, and sometimes through the walls as well. So what the takeaway from here is, remember in all your design to have something called as an electrical shaft, right? An electrical shaft which is going to be a core continuing from ground floor till the top floor without changing its location. There are several ways of doing it. I'm not saying this is the only way, but to avoid to be able to understand, probably this is a good starting point, where you have your core shaft at the center. Of course, if somebody can think the next step, I'm just saying the core shaft position alone have to be same. The electrical room can change its position. It can happen this way or it can happen this way, but what cannot change is the shaft location, right? So by doing this, you are eliminating so much of other problems which will enable yourself to focus on the design aspect of it, the aesthetic and architectural part of your designs. So retain the shaft, plan your shaft location, and plan your electrical rooms and which side they are going to come. Make sure your door opens outside, at least for all the services rooms, right? So this is how the design is going to be impacted by your planning of electrical services, or for that matter any services. So why did we select this point? Why can't it be here? Why can't it be here? Why can't it be anywhere else? It's up to the architect and the electrical consultant and the engineer. But again, there are several ways of zoning it. I just divided it into 2 zones. It can be as well as 4 zones, or it can be just 1 zone where you have this one shaft and the electrical room communicating and vertically and horizontally across all those rooms and floors. There are so much of possibility. Of course, like your architectural finishes, there are so many factors which is playing a role here. Depending on that, we can have several strategies. But again, remember this: shaft location, electrical room location, and the door opening. So now we go back to the PPT. Thank you. We have come to the last and final phase, subtopic of our module 1 part A topic, codes and standards. So obviously the first one to refer is first one that comes to our mind is National Building Code, but of course we have something else called as National Electric Code before the National Building Code, which is an exclusive code for electrical norms, rules and regulations. Of course, we also have NBC, which actually refers back to your NEC at several instances, and third is our BAS standards, and fourth is your the first 3 are going to be national standards, and the fourth one is going to be your customized standard for your from your state electricity board and chief electrical inspectorate guidelines. On top of all this, we have Indian electricity rules. So all of them will definitely have harmony between each other. There won't be any clashes between any of these, but at the same time we will have to thoroughly understand what each of them talks about and when and where to refer each of this. So let me start with National Electric Code, which is developed under the Electrotechnical Division, Bureau of Indian Standards. It talks about the good practices for various selection of items of electrical equipment forming various part of power systems, recommendations concerning safety in terms of wiring installations, and general safety procedures and practices in electrical work, additional precautions to be taken for electrical equipment for special environmental conditions like explosive and active atmosphere. right? So more or less it talks about good practices, safety procedures, precautionary measures, and all that. And this is of course harmonized with corresponding Indian Electricity Code standards. So National Electric Code applies to this is just the contents of NEC to understand what are the type of buildings that National Electric Code can cover. So I've listed down a couple of building typologies which you can refer to, and so those are the typology of the buildings, and this is the content of NEC. It talks about common aspects to electrical installations, to domestic dwellings, substation, from the generating stations to the substation, to the buildings, to various other agricultural premises and all that, electrical installation in hazardous areas, and it concludes with solar photovoltaic power supply system, which is recently gaining more attention. From an examination point of view, again, one repetitive question which keeps coming is code of practice for electrical wiring installations. So only for the wiring, if you have somebody who is looking to answer this particular question which gets repeated, probably which will help you in the preparation of exams, you will have to go to IS 732/1989, which is reaffirmed in 2005. Search for this code, you will get the electrical wiring installation codes. And if at all you feel there is a clash between any of this, Indian electricity rules and Indian standards take precedence over all other standards. We'll again, National Building Code, most of you must be aware, but still, this is a prime code for all commercial buildings. It talks about DCR, general building related requirements, fire safety requirements, stipulations regarding materials, earthing, lightning protection, and earthing for high-rise buildings. And then comes the Karnataka Electricity Board. This is again an excerpt from the website of Karnataka State Electrical Inspectorate, ksa.gov.in. So they talk about that these are the set of acts and rules and regulations which is made under the guidance of State Electricity Electrical Inspectorate. So somebody who is interested in downloading can go to the link that I have provided below. That will take you to the main page where you can download each of this and understand what is the recommendation from the standards perspective. And with this we complete this module 1 and subheading 1 aspect of this particular subject. So next will be our module 1 subheading 2. Thank you.